Okay, so now in this example, we're going to look at understanding unions and intersection of sets. So let's jump right in. So in this example, we're going to define the set A as the numbers 1, 2, 3, 4, 5. And set B is going to be the odd whole numbers, right? 1, 3, 5, 7, 9. So that's going to be set B. And in set C is defined by the elements of 2, 4, 6, 8, and 10. Okay? So those are the three sets that we're defining. Now, in these parts here, we want to list the elements. So each one of these represents a set of elements. So what we want to do is we want to give the set of elements that each one of these operations represents. So what does it mean? So A union B. So for part A, so A union B, that means we want everything in A, we want everything that's either in A or B or both. Okay? So what does that mean? We're going to count everything, we're going to include everything, and get rid of any duplicates. So that means this is going to be the set of A. A is 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Now what we want to do is we want to include anything that's in B that is not already in A. Okay, so B includes 1, 3, 5, 7, and 9. Well, we've already got 3, 1, and 5 in there. Okay, so we don't need to write those again. So we've already got the first 3, but we don't have 7 and 9, so let's add those. And so A union B is represented by this set. And that's it. We're done. That's the answer. Now, what about A union C? Well, if we look at A union C, right? Let me move this down a little bit, give myself some room. Okay, so now, A union C means, again, what does the union mean? This means I want everything. I want everything that's in A and everything in C. I want everything, and then get rid of any duplicates. Okay, so again, I'm going to start with A. So the set A, so that gives me 1, 2, 3, 4, 5. Okay, so 1, 2, 3, 4, and 5. And now I want everything that's in C that I haven't already written down, okay, from A. So I've already got 2, I've already got 4, but I don't have these, so I'm going to take these 2. So this is going to be 6, 8, and 10. And so that's the answer for A union C. Okay. Now what about B union C? B union C means I'm going to take all of these numbers and I want all of these numbers. They have nothing in common, right? So that means there are no duplicates. So I want everything in both of these together. So that's going to give me everything from 1 to 10. So that means B union C is going to be 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. And so that's the answer to B union C. Now, what about the intersection? Now we're going to do the same thing, but now we're going to take the intersection of these. So intersection means I only want what's in both. Okay, that's it. I just want what's in both sets. So if I say A intersects B, well, I only want the elements that show up in both sets. So A and B. So what elements show up in both A and B? Well, 1 does, 3 does, and 5 does. That's it. So those are the ones I want to write down. So 1, 3, and 5. That's it. That's the intersection of A and B. Okay, now, What about the intersection of A and C? Well, now we want only what's in both of these. Well, what's in both? Well, 2, 4, and that's it. So the intersection of A and C is just going to be 2 and 4. Okay. Now, the final one, B and C. Well, what's the intersection of B and C? Well, again, when it comes to intersection, it means we want what's in both. So, are there any common elements in both B and C? The answer is no. So that means that B intersects C is the empty set. Another term to use in this case is whenever we have the intersection of two sets is the empty set or the null set, we say that these two sets are disjoint. They don't overlap. Okay? So in this case, the way we would visualize this is it's two sets that don't overlap. So this would be B and C. So this is what we mean by disjoint sets. You can think of disjoint circles. Okay? Circles that do not overlap. Another term that's used, not necessarily in this class, but in probability and other types of other classes, is this is what we call mutually exclusive sets as well. So disjoint, mutually exclusive are interchangeable, but we typically use disjoint. But again, keep that in the back of your mind. That's it. Have a great day.